same region. And we can compare this with universes we create on computers. Here's a closed universe where the lumps are bigger. They should be this big across. If they're 100,000 light years across, they should look that big. Well, that's bigger than these lumps. Here's an open universe, and you can't see the resolution of the screen isn't that good, but the average size lump is about that big. Smaller than these lumps. But just like Goldilocks, in a flat universe, it's just right. In fact, it's right now, we know, to an accuracy of better than 1%. The universe is flat. It has zero total energy, and it could have begun from nothing. And I've written a piece, although of course I got a lot of hate mail, saying that in my mind this answers this crazy question that religious people always keep throwing out, which is, why is there something rather than nothing? The answer is there had to be. If you have nothing in quantum mechanics, you'll always get something. It's that simple. It doesn't convince any of those people, but it's true. Now, great, we know the universe is flat. But if you've been awake, you realize, 10 minutes ago I proved the universe was open. There's only 30% of the stuff in the universe needed to make it flat. Where's that other 70%? Well, if you put energy in empty space, so empty space weighed something, you wouldn't see it. It's the empty space between the galaxies. You're far away from the galaxies, you wouldn't see it. But what would that empty space do if you put energy in it? Well, it produces a cosmological constant. That would cause the expansion of the universe not to slow down over time, as any sensible universe should do, but to speed up over time. In 1998, people measuring these supernovae at large distances to measure the Hubble diagram tried to see what was happening at large distances to see if the universe was slowing. Well, they all knew the universe was slowing down. They wanted to measure how much. This doesn't look like much, but it was a revolution in cosmology. I can draw a straight line through that data set there and bring the whole thing down and make it horizontal. And if the universe was slowing down, these distant supernovae should have followed this curve. Much to the surprise of the observers, the supernovae lay above the straight line. And the only way to explain this, well, there's two ways. Either the data is wrong, which it usually is, or the universe is accelerating, speeding up. And if just for fun one believed it was speeding up and asked how much energy would you have to put in empty space to make it speed up by the amount we measure it, it's exactly the amount we are missing. Everything holds together. Our new picture of cosmology is that we live in a universe dominated by nothing. The largest energy in the universe, 70% of the energy in the universe, resides in empty space. And we don't have the slightest idea why it's there. Now, that's what I just said. Let me also put an aside before I get on to the rest in the last 5 minutes of the talk. This completes, in some sense, the ultimate Copernican principle. Copernicus told us we didn't live in any place special. We now know two things. Well, one thing. I'll tell you the second one in a second. This tells us that we are more insignificant than we ever imagined. If you take the universe, everything we see, stars and galaxies and clusters, everything we see, if you get rid of it, the universe is essentially the same. We constitute a 1% bit of pollution in a universe that's 30% dark matter and 70% dark energy. We are completely irrelevant. Why such a universe in which we're so irrelevant would be made for us is beyond me. Okay, good. Now I want a little bit of applause. Now we can go back to the science. What I really want to spend in the last few minutes is telling you is how it's changed our picture of the future. In science and the picture of the universe. It has changed our picture of the future completely. And I'm going to rush through this, so let me give you the short answer first. Kurt Vonnegut has claimed as having said this at a private girls' school when he gave a commencement address. I've given 2 commencement addresses and I've never had the guts to say it, but I'd love to. He said, things are going to get unimaginably worse and they're never ever going to get better again. This was before the Bush administration too, in fact, but that's our understanding of the universe. I want to tell you about it briefly. I want to tell you about a few things that you'll hear about and some of the things that creationists and intelligent design people promote as arguing somehow that there's design in the universe. This is one of them. And I want to explain to you why it has nothing to do with design. It is weird and strange that we live in a universe that looks like we do, because this is a brief history of time. This is the density of matter as the universe expands. It goes down as 1 over the volume. But it turns out the energy density of empty space remains constant as the universe expands. And we live today, right here, when the energy density of empty space is 3 times bigger than the energy density of matter. But when you look at this has driven physicists crazy. Because this is the only time in the history of the universe when these two numbers are about the same. At all earlier times, the density of matter was much greater. At all later times, the density of empty space will be much greater. Why do we live at this special time in the history of the universe? Well, one of the answers that's been given is that these things exist, galaxies. Why? Well, let's go back to this picture, and let's pretend the energy of empty space were 50 times bigger. Then these two curves would cross, not now, but then. Well, when is then in this case? Then is the time when galaxies first formed. But if the energy of empty space was bigger than the energy density of matter when galaxies first formed, then the repulsive force would be greater than the attractive force. Galaxies would never have formed. Well, if galaxies never formed, then maybe this is telling us something. And this has produced something that I call anthropic mania. If there are many different universes, physicists have argued, and the energy of empty space can vary in each one, then only in those in which it's not much greater than what we measure today will galaxies form. Okay? But then, only then will stars and planets form, and only then will astronomers form. So the universe is the way it is because astronomers are here to measure it. Now, it not only sounds ridiculous, but it also sounds religious. And some people have said the universe is fine-tuned. If it were any different, then we wouldn't be here. God clearly created the universe to be for us. Now, that's nonsense. And it's nonsense for the same reason that you learn so beautifully in Richard's books. Why can bees tell the colors of flowers? So they can find them. Not because God intended them to do it, but if they couldn't find the flowers, they wouldn't get the stuff they needed to eat, and they wouldn't be around. It's natural selection. And what RIS is really telling us is kind of a cosmic natural selection. Because all it's saying, if it's true, is that it's not too surprising that we find ourselves living in a universe that allows life. Because in the universes that don't allow life, we wouldn't be here. It's just that simple. So if you wish, it's a kind of cosmic evolution. Or cosmic natural selection is a better way of thinking about it. Now, as pretty as that is, I think it's wrong. It's ugly. And it goes against everything I know about science. Science has told us the last 400 years why the universe must be the way it is, not why it has to be something different. In fact, Einstein once asked a question. He said it the wrong way. Put it here because, I wanted to quote him. He said, what really interests me is whether God, and by God he didn't mean God, had any choice in the creation of the universe. What he really meant is, are the laws of physics fixed so that if you changed one parameter, you couldn't have a universe? Or can you have infinite numbers of different laws of physics that all work, and it just happens to be the way it is? If this anthropic picture is right, then physics is really an environmental science. There's no fundamental laws necessarily. We're just here by an accident. And the laws of physics are the way they are, not because there's some beautiful mathematical theory that tells us they have to be, just because if they were different, we wouldn't be here. Now that I find repugnant, although it may be true. And I was going to spend time telling you about that, but I'm really behind, so maybe I shouldn't. Let me just say that there is a theory that suggests, in such a picture, if there are an infinite number of universes, then you don't need a theory of everything. Forget what I wrote there. You need a theory of anything. You just need an infinite number of universes and some theory that tells you anything can happen. We have such a theory, and I did want to spend 1 minute telling you about it. It's called string theory. Here's the brief summary of it. One person said to another, I just had an awesome idea. Suppose all matter and energy is made of tiny vibrating strings. The second guy says, okay, what would that imply? And the first guy says, I don't know. So that's a history of string theory in the last 25 years. And The point is, it is fascinating for many people, but